Sir,
Yes, yes,
before you start, I have a question.
yes.
বলবো?
হ্যাঁ, বলো।
হ্যাঁ, এই যে আপনি বললেন
So let us start with this particular simplex method. And I shall write once again the system of equation which we got from our earlier session. Let us write it. So ultimately we have got max of z prime, which has now become 3x plus 4y plus 0 into s1 plus 0 into s2. The contribution of s1 in the objective function is nil. Contribution of s2 in the objective function is nil. So they have been multiplied by 0. Otherwise, the objective function will change, and that we do not want. Subject to the constraints which we have got is x plus 2y plus 1 into s1 plus 0 into s2, which is equal to 0, which is equal to 2. And the second one is 2x plus y plus 0 into s1 plus 1 into s2 is equal to 2. And all these variables xy, s1, s2, all these variables are non-negative. Now you carefully listen to me and don't blink your eyes, because this part is the harder part. Simplex table requires step number 2. We shall construct some simplex tables until we reach at optimal solution. Okay, and with this point in mind, let us construct our simplex table 1. Simplex table will have some, format, and that format you have to keep in mind. I'm going to write the format of the simplex table first of all, and throughout the process, this format of the simplex table will be maintained. After I writing the format, I shall tell you what are the meanings of this particular uh, terminologies which I shall be using over here in simplex table 1. So I'm going to construct my simplex table 1. What is the format? Let us write it. Cj, here I shall write Cj, then below this I shall write xb. Okay, preceding to that I shall write capital B, preceding to that I shall write cb, and corresponding to this, how many variables are present in the system? X, Y, S1, S2, X, Y, S1, 4 variables are present. I shall write all the 4 variables, X, Y, S1, S2. Below that, I shall write a quantity called ZJ, and there I shall write Zj minus Cj. This is the format of the simplex table with another extra column which is called minimum positive ratio, which is xb by something, some quantity will divide xb, that will be told to you later on. This is the format of the simplex table, and that will be maintained in all the simplex tables that we are going to draw in this particular example. First of all, let me talk about what is Cj. Cj is called the contribution of the variables x, y, s, all the variables present over here, the net contribution of these variables in the objective function. So your Cj is, let me write over here, Cj is net contribution of all variables into the objective function, Okay, so let us fill it up. What is the contribution of the variable x in the objective function? It is 3 units. What is the contribution of variable y in the objective function? It is its coefficient, 4 units. The contributions of s1 and s2 in the objective functions are 0 and 0. So we are putting 0 and 0. What is capital B? Capital B is known as basic variable. Basic variable. And what is xb? Xb is called value of the basic variable. Value of the basic variable. Okay. So how to find the basic variables? So there is a theorem. The theorem says that first of all, you count how many variables are present over there. So you write number of variables. How many variables are present? You can see that here in this problem, there are 4 variables. How many equations are present? Number of equations is 2. So the theorem says the variables the theorem says let us denote this 4 by n in general, and that we denote by m. Small n equations and small m unknown, small n unknowns and small m equations. So the theorem says n minus m variables will be basic variables. Okay, and any basic variables. So here in this particular problem, according to this rule, 4 minus 2, that is 2 variables will be basic variables. 2 variables will be basic variables. Okay, and we shall put 0 value to the basic variables. In the simplex method, there is a convention. The convention is that if this is the scenario, and if the slack variables are present, in the system, so you choose your slack variable s1, number of slack variables which are present over here, you choose from there and consider these slack variables. First of all, let me talk about that. The rule says if slack variables are present with the original variables, these are my original variables x and y, okay, and slack variables are my introduced variables, then you consider all the original variables no here one mistake I have made. The theorem says that n minus m variables will be, sorry, it's not basic, n minus n variables will be called non-basic variables, and we shall put 0 value to the non-basic variables. We shall put 0 value to the non-basic variables. The convention says that the original variables which are present in the system, that is x and y, these will be considered as non-basic variables, and we shall put 0 value to them. We shall assign 0 value to them. These variables are called non-basic variables. It is a convention. It is a convention in the simplex algorithm where we shall consider the original variables to be the non-basic variable. After putting x equal to 0 and y equal to 0 in the system, the value of other variables will be obtained. So if you see that if I considered x and y to be non-basic, and if I put x equal to 0 and y equal to 0, then what we will get? We will get 0 plus 0 plus S1 is equal to 2. Now S1 has got a value which is 2, and therefore we shall put S1 in the column B with its value 2. So after putting non-basic variables, after putting 0 values to the non-basic variables, the values which will be obtained for the remaining variables are called the value of the basic variables, and the remaining variables present in the system are called the basic variables. So here I am considering the original variable to be 0, and by putting 0 over here, I am getting S1 equal to 2. So S1 now becomes my basic variable with the value 2. Similar is the case with the second one. If I put x equal to 0 and y equal to 0, and 0, if I put here, actually S1 is not present because its coefficient is 0. So if I put x equal to 0 and y equal to 0, we get S2 equal to 2. So S2 is my second basic variable with the value 2. So B, what is B? B is the basic variable column, and XB is the value of the basic variable column. All have been obtained. What is CB? CB is the coefficient of basic variables. Coefficient of the basic variable in the objective function. In the objective function. So once I identify the basic variables here, S1 and S2, we can immediately see that its coefficients are 0 and 0. So we are putting these coefficients over here, 0 and 0. Okay. And what about this particular part of the matrix, of the table? We shall put all the coefficients present in the system. So first row corresponds to the first equation. Second row corresponds to the second equation. In the first row, what are the coefficients? X has got the coefficient 1, so put 1. Y has got the coefficient 2, so put 2. S1 has got coefficient 1, so it is 1. And S2 was not present in the first equation, so its coefficient is 0. That's why I put 0 into S2 over here. Second row corresponds to the second equation. In the second equation, the coefficient of X is 2, so put 2. Coefficient of Y is 1, so put 1. Coefficient of S1 is 0. Coefficient of S2 is 1. So we have got our matrix. Now we are going to calculate Zj. The formula of Zj is like this. CB represented in column will now be represented in terms of row. So we are writing CBT, and that will be multiplied by the value, by the variables in its column form. Okay, so we can consider this to be capital X. Capital X is actually all the variable. I'm considering all the variables. Capital X is sometimes X, it is sometimes Y. It is for the next column, capital X is your S1. For the next column, capital X is your S2. So all these possible values of X will be considered. And if I consider X equal to X, means this column. So I'm showing one of the calculations to you. CBT is fixed. So I am considering if this is the column matrix, we can write it in the form of row matrix 0, 0. And X is taking the value small x, it is a column vector. So I'm multiplying this by the 1, 2, column matrix 1, 2. So we can easily multiply the matrix. So it will become, if you can recall the multiplication of two matrices, you can see that this would be 0 into 1 plus 0 into 2. This 0 into 1 plus that 0 into 2, which is equal to 0. So we have got our first value of the Zj for the column X, which is 0, by this rule. Okay. Similarly, if you apply X equal to Y, so we need to consider this column, and this row will multiply the column from the left hand side. So again we shall get 0, here 0, and here 0, by the same rule, by the same matrix multiplication rule. And Zj minus Cj means we have to subtract the values of Cj's from the corresponding value of Zj. So it will be the first column. For the first column, the value of Zj minus Cj will be 0 minus 3, that is minus 3. 0 minus 4 is minus 4. 0 minus 0, that is 0. 0 minus 0, that is 0. My construction of the simplex table 1 is done. Now I want to do the next simplex table in this particular page only, for which I am going to omit certain portions. I am going to omit this part which I have written, because if I go to the next page, then I have to fluctuate between the pages, which is not, I mean, because you are the first timers, it would not be actually feasible for you. So I am actually deleting some of the portions from this whiteboard. First of all, let me delete this portion. I think this portion you have already copied, and if you have not, then you can ask me, I'll tell you, you can copy it. So I'm deleting this portion, and I think this is not required. And also this part is not required. And I want to delete this portion also. So if you have any objection, if you have not copied, or if any objection, you can raise your hand. Otherwise, I'm going to delete this portion also. I shall just keep the simplex table here in this particular page. So I'm deleting this. These portions which I have deleted will not be required further. Their jobs are done. Okay. Now this is my simplex table which I have got. What is the optimality condition of this simplex table? When do we say that this optimality has been reached? So the checking criteria is if all the elements of Zj minus Cj are greater than or equal to 0, we reach at optimality. If at least one Zj minus Cj is negative, we have to proceed further. Probably now you have understood that how complicated the simplex method is. So since you are learning simplex method for the first time, and if I would have taken a three variable problem, so it would have been much difficult for you to grasp the idea. So that's why I have considered a system of equation which has already been solved by graphical, but it is containing two variables only, two equation, so that I want to minimize the calculation part. Once you are equipped with this, then you can take any number of variables. Now you see that this particular Zj minus Cj contains not one but two negative numbers, minus 3 and minus 4. So in no way, by this rule, this simplex table 1, in no way it is the optimal table. So we have to proceed further. We have to construct another simplex table. So let us write simplex table 1, simplex table 2 just beside it. And as usual, I'm going to draw the format first of all. So first of all, I'm going to write Cj just as I did earlier, XB, CB, capital B. You know, now you know the meanings of this, XY, S1, S2. And below that, I'm going to write ZJ and Zj minus Cj. The upper portion is quite obvious. This will always contain the net contribution of the variables, so that will not change. 3400, which comes from the objective function, we'll substitute that. But rest of the things will change. What we are going to do? The first of all, if this happens, what we need to do is that try to identify the smallest negative number in Zj minus Cj. Okay, so what is the smallest negative number in the Zj minus Cj? Which one is the smallest, minus 4 or minus 3? If you think of the number line, minus 4 is smaller than minus 3. Minus 3 comes on the right hand side of minus 3. So this is the smallest. We are going to put a arrow mark like this over here. This arrow mark means this variable y is called the entering variable. What variable? This variable will be called the entering variable. Why it is called the entering variable? Because this variable is going to be entered into the basis now. It is called the entering variable. It will take some place, either this place or that place in the basis. Basis means the set which contains the basic vectors or basic variables. But these places are already occupied, one by S1 and another by S2. So one has to leave. Which one? Now, two people are sitting in the classroom. I want one of the students to get out of the classroom, but I cannot forcefully do so. So I have asked two of the students one question, and the person who was not able to give me the answer, I am just throwing him out of the classroom, or I am tossing the coin with head and tail. I can do it in a various way. So here also, for the departing variable, we need to have some kind of mathematical rule. And that mathematical rule will be given by this particular part, minimum positive ratio xb. This column which has been identified, or with this column which has been identified with containing the entering variable, is called the pivot column. Column containing entering variable is called pivot column. So here I shall put pivot column. And pivot column means the values of this basic variable will be divided by the corresponding value of the pivot column. So here the value of the basic variable is 2. So I am writing 2. Corresponding value of the pivot column is 2. So 2 by 2, which is 1. Here the value of the basic variable is 2. I am writing 2. Corresponding value of the basic variable is 1. So I am writing 1, 2 by 1, which is 2. And since this name is there, minimum positive ratio, so you obviously know that this is a ratio, that is a ratio. So minimum of them is 1. So that minimum positive ratio, beside that, I'm going to put an arrow like that, and that will indicate that corresponding to that arrow here in this row, this variable will leave its position, and that variable will be called the departing variable. This is the departing variable. Let me write it clearly. It has become hazy. Departing variable. Okay. Now, by keeping this in mind, I'm going to construct my next simplex table. And the row which contains the departing variable is called the pivot row, is called the pivot row. Okay, so the first row is the pivot row. The second column, I mean, I'm counting from here, not second column. These columns are actually fixed always. The variable columns, the variable column, it is the second column. The second column is the pivot column. The first row is the pivot row. S1 is going out from the classroom, so it will leave its position blank, and in that position I am going to bring y, because y is now my new variable, basic variable. S2 is not hampered, so S2 will keep sitting, and he is trembling that when the sir is going to ask him question. So that is S2. His time hasn't yet come. And y, once y entered the classroom, the teacher is asking, what is your contribution in the objective function? And y is replying, my contribution in the objective function is 4. So the teacher is noting, what is your roll number? My roll number is 4. And S2's roll number is 0, because here in the classroom the roll number starts with 0. So I am putting 0 over here. Now, what will be the change in this matrix values? Okay. First of all, listen to this particular part very carefully. First of all, you see one thing, that this is the pivot column and this is the pivot row. They are intersecting at which point? Pivot column and pivot row, they are intersecting at this point. This is the point of intersection. And that point of intersection, the point of intersection of pivot column and pivot row, the point of intersection of pivot column and pivot row is called pivot number. Here the pivot number is 2. In this table, the pivot number is 2. I shall write the first row of the simplex table. I shall write the first row of the simplex table in a manner so that pivot number becomes 1. And the pivot number can become 1 if I divide the first row by the pivot number itself. Since the pivot number is 2, I want to make it 1. So we can divide the pivot number by itself so that it becomes, this position takes the unity. So I am dividing this row, entire row, by 2. I am dividing the entire row by this pivot number, and by doing this, I am getting 2 by 2, that is 1, and 1 by 2, that is half, and 2 by 2, that is 1, 1 by 2, that is half, and 0 by 2, that is 0. Remember, this was the position of the pivot number in the previous table. Now this particular row has changed its form in the new table, new simplex table. This particular row has changed its form, its elements have changed. So we shall not consider this row any further. So I am not considering. You do not cross it out, because I am doing it because I have the provision of erasing. So I am not considering these elements any further, because they will not be required. They have changed now. I want to write the second row now. Second row can be written in the following manner. Since this is the position of the pivot number, this was the position of the pivot number, which is indicated by star. And you see that here in this position 1 is present, and here below that 1 we have 1 in the previous simplex table. So if we consider this to be the old row 2 and this to be the new row 1, I am going to make this position 0. Pivot number will be a number. This position will be succeeded and preceded by 0 always. So I want to bring 0 in this position, but here it is 1. So I want to actually make this as 0. What I will do, I will subtract from R2 old the R1 new, where R2 old is the old row and R1 new is the new row 1. Okay, so if I do so, what will I get? 1 minus 1 will give you 0. Fine. 2 minus 1 will give you 1. 2 minus 1 will give you 1. 2 minus half give you 2 minus half will give you 3 by 2. 0 minus half will give you minus half, and 1 minus 0 will give you 1. Okay, and once I do it, I shall again calculate Zj with this formula. So now we are going to get, we are now going Zj as 4 into half plus 0 into 3 by 2. 4 into half means 2. So I'm writing here 2. 4 into half is 2. That is, I'm writing here 2. I'm using this rule again. 4 into 1 plus 0 into 0, that is 4. 4 into half plus 0 into minus half, that is again 2. 4 into 0 plus 0 into 1, that is again 0. And Zj minus Cj will be 2 minus 3, that is minus 1. 4 minus 4, that is 0. 2 minus 0, that is 2. 0 minus 0, that is 0. Now, unfortunately, this particular simplex table also is not optimal, because in this simplex table, in the Zj minus Cj row, the negative number exists, which is minus 1. And if Zj minus Cj doesn't contain the non-negative numbers, then in that case, we cannot say that optimality has been reached. Okay, so I have to construct the simplex table 2. Simplex table, not 2, simplex table 3. Okay, and I am going to omit this portion. Since the time is running out, I am quickly writing what I have obtained. I'm quickly doing the calculation because I have to finish this particular problem in this session by hook or by crook. So let me do it. So we shall consider the minimum positive ratio column here also, because we know already that this gives us the departing variable. Let me write quickly the format of the simplex table. Okay, and you see that this is the most negative number, because only negative number present over here is minus 1. So this is your entering variable, and if I calculate this xb by pivot column, that is x1 by half, which is 2, and 1 by 3 by 2, which is 2 by 3. So 2 by 3 is obviously lesser than 2. So that is your departing variable. So now S2 is your departing variable. So I'm quickly writing the matrix, which I have already solved here in my copy. And by the similar sort of calculation I have obtained this 3, 4, 0, 0. Y will remain same because it is not departing. S2 will be replaced by X. The contribution of Sy in objective function is 4, and the contribution of X in the objective function is 3. And by the similar sort of calculations we have obtained by the row operations. What have I done in the previous matrix, that is by considering the pivot column, first writing the pivot, making the pivot number 1, and then making the numbers present below and above the pivot number as 0. Similar sort of calculation have been done, and we have got this matrix, I mean this table, which is 0, 1, 1/3, minus 1/3, 1, 0, minus 1/3, 2/3, and the calculation or the matrix calculation gives me 3, 4, 1/3, 2/3, and Zj minus Cj gives us 0, 0, 1/3, and 2/3. Now you see all the elements present in Zj minus Cj, all the elements present over here are non-positive, non-negative, and therefore simplex table 3 is my optimal table. Interesting to note that in the simplex table 2, in simplex table 3, we have got the values of the variable. X has become 2 by 3 and y has become 2 by 3. And since in the basic variable, this is the solution space. In this solution space, since S1 and S2 are not present, so S1 and S2 are having values 0 because they are removed from the basis. They are removed from basis. And this particular solution is telling with the solution obtained by graphical method. In the graphical method also we have obtained x equal to 2 by 3 and y equal to 2 by 3. Time is running out. I'm pausing here.